One of the bigger problems, obviously, with water pollution is sewage. We have a lot of sewage that is transported over long distances and oftentimes is being transported alongside waterways. Then, of course, if you're from a non-city, you know that we don't have, like, I'm from Tennessee. I'm from East Tennessee. We didn't have sewers where I grew up. We had, basically, where I'm from in East Tennessee, we didn't really have sewers. We had septic tanks, and septic tanks, like anything you put into ground and then you fill with pollutants, has the potential to be highly problematic. And so sometimes septic tanks leak. Sometimes they don't just leak. The septic, sewage basically leaches out of the septic tanks, depending upon how old the septic tanks are. In a similar but obviously different type of pollutant situation, one of the big problems we have right now with groundwater pollution is stems from old gas stations. So old gas stations, they keep gasoline underground in these big huge tanks. You've probably been to the gas station and seen them pumping gas into the tanks. Well, these tanks, especially old ones, are prone to leaking, and so you can imagine, like, how many old gas stations are there in the country. I mean, in my hometown, I can think of 4 or 5 previous gas stations that are no longer there. And what's interesting about all 5 of those gas stations is nothing else is there. These are like out of business gas stations, and nothing else has been built. And I I would have to obviously confirm this, but I'd be willing to bet that one of the reasons why nothing's been built there is because the ground is so contaminated with gasoline that it's just not safe. You don't want to dig that ground up. You don't want to bring it to the surface. And then, of course, with water pollution, the concern is that leaching of the pollution from these tanks is going to eventually make its way into groundwater. And that's, of course, highly problematic. But with, like, national effluent standards, this is specifically referring to sewage, and sewage making its way into waterways. Historically, there's been a fairly large enforcement problem. It took a long time for sewage systems to make their way about the entire country. The US is a very big place, and we have some very rural places, and those rural places often don't have, like I was just mentioning, they don't have sewer systems, they don't have new septic tank systems. And so as a result, enforcing national effluent standards became very difficult because not every place had the same ability to prevent effluent, that is sewage, from making its way into waterways. Um, as we've discussed very often in this class, when we talk about cost effectiveness, one of the things that we know about cost effectiveness is that if sources have different cost of remediation, then each source would need to have specific standards for it. But as is often the case, we sort of pick one size fits all standards, and anytime you pick one size fits all standards, that becomes a potential complication. And studies subsequently have shown that uniform standards do not come close to approximating the least cost allocation. So, like a lot of air pollution, economists believe that we could reduce water pollution in a much cheaper way than we have historically done it. And one of the ways that we could made that process cheaper is by setting standards specific to specific sources, as opposed to doing these top-down, one-size-fits-all approaches. That's going to be a common theme in environmental econ, is that we need to look at not just pollutants and regulate pollutants in particular ways, but pollutants from particular sources will often need to be regulated in particular ways. Just like we see with air pollution, with water pollution, there's this possibility of market-based mechanisms. One such example of market-based mechanism that actually has been used and has attempted to be used in actually this particular region of New York State is so-called watershed-based trading. So this is where you trade for water pollution control, involves the point source polluters meeting water quality standards by purchasing reductions from other sources with lower marginal abatement costs. So it's just like before with air pollution. Those firms for which abatement cost is really high are going to buy pollution permits from those firms whose abatement costs are very low. And that makes abatement a naturally more cost effective process. And of course, much like we see with air pollution, this trading program could have large economic benefits as well as be faster and cheaper. You know, imagine for a moment that market-based mechanisms not only are cost effective, but they help to remediate the problem in a much faster fashion. That would seem like perhaps a very good idea. But also, as is the case with air pollution, the realities of water pollution, for example, the spatial distribution of pollutants, the different types of land uses, residential versus commercial versus agricultural, you know, going back to this issue of like agricultural runoff, oftentimes farms have to get special carve outs from their local and state governments simply to be able to run themselves because they produce so many pollutants that if this was just a normal house, there was no way they would let someone in just a typical house pollute that much. But because it's a farm and the farm has positive economic benefits, the state and local regulators will make carve outs for them. Well, again, if you have carve outs in one state, you may not necessarily have carve outs in another state. And so that can make these watershed based trading complicated and difficult, as is the case also with pollution. Interestingly enough, New York State and specifically the Long Island Sound Comprehensive Conservation and Management Plan sought to create a watershed-based trading system, and it would be focused on that TMDL for nitrogen. So this is specifically that total maximum daily load that we were talking about previously with respect to nitrogen. I said nitrogen is a big water pollutant. We know kind of how much nitrogen we can allow into water before it becomes a problem. And so that's where that total maximum daily load comes from. And so the idea is that's the standard. The standard is total maximum daily load. And then we offer pollution permit trading to that particular standard, right? So that's what we mean. When we say cap and trade, that's what watershed-based trading is. It's cap and trade. We cap pollution at the total maximum daily load, and then we offer permits that would achieve that total maximum daily load. And we only allow those permits. And so, therefore, we get the pollution amount that we want, and we allow firms to trade permits. And by allowing firms to trade permits, theoretically, we get a more cost-effective approach to doing so. Unfortunately, this has yet to be fully adopted. It was more of an ambition that has not necessarily come to fruition. But just to give you an idea of like the complication here, to implement nitrogen credit trading, a watershed permit, a general permit issued to all sources is called for, which will include all 84 municipal point sources and will establish an annual nitrogen reduction requirement for each source based on its normalized proportion of the total reduction. The permit level will be reduced each year for 15 years based on the amount of nitrogen remaining after completion of construction of wastewater facilities until reaching the total maximum daily load. The single permit linked to the financing schedule of the Clean Water Fund, that includes the state grant and revolving loan fund authorized by statute, will be subject to a single hearing, an appeal process, and allowed sources which may choose not to be included will be immediately be subject to their WLA. And so, again, you could just see this is a complicated thing to do. Even just talking about it kind of, sort of brings it up. This is another example of a watershed trading program that actually was implemented. And this one dealt with the tar Pamlico nutrient trading program. And so it has the possibility to be implemented in places, and we see it. So the point here is that the watershed-based trading, much like market-based mechanisms are starting to be used more often. So we're seeing, air pollution taxes, and we're seeing water pollution taxes, essentially. We're starting to see these used more and more and more. So it seems like the influence of environmental economics is making a difference and is offering policymakers, both at the federal as well as state and local levels, to have more options at their disposal, no pun intended, which is great, which is fantastic, right? So despite the fact that water pollution kind of continues to be this big problem, all right, there's this possibility that, much like air pollution, we can really start to tackle it and make a serious dent into that particular problem. And so, efficiency and cost effectiveness. So, GIS here refers to geographic information systems. Geographic information systems are really important because, again, water pollution is so interconnected, that there's such a spatial component to water pollution that GIS becomes a very important part of our ability to understand water pollution. Of course, things like land use changes, going from agriculture to a more, residential to maybe a more commercial. Those are all going to have profound effects on the soil composition, the ability of the ground to absorb pollutants, right? I mean, you can imagine if you have a piece of land, the permeability of that land is changed whenever you dig a bunch of the land up. And so you reduce the dilution effect of land. So land can take in a certain number of pollutants and dilute their effect. But if you're disrupting the land because there's a lot of construction and a lot of development, then that potentially also reduces the ability of land to withhold those pollutants, and they're much more likely potentially to make their way into the waterway. With new technology, we have a much more real-time focus on water pollution and the ability to monitor water quality in a much more sophisticated way than we did previously. So one of the things that's nice is that people actually can know if the water they're drinking is safe, for example. Although, of course, there are numerous instances where those systems fail. Notably, Flint, Michigan, for example, had a water quality system completely fail due to lead contamination. Similar issues with respect to lead contamination in drinking water historically have been found in Newark, New Jersey, as well as Washington, D.C. The Washington, D.C. one was especially famous because it specifically was the water quality of drinking water in schools in DC and in schools, elementary schools in Newark, New Jersey. So that was like, kind of grabbed some headlines when it first came out, although you don't really hear much about those particular issues now. People seem to have kind of forgotten about them. Flint is something that people still talk about, and with good reason. But again, that Flint is a great example of the limits to technology. At the end of the day, you still have to care about water pollution. It doesn't matter how good the technology is. If you don't care about it, then you're still going to have a problem with it. And that's what happened in Flint. Nobody cared about water pollution in Flint. And so it became, this huge problem. Obviously, one of the bigger issues we have with water pollution is the way we treat municipal wastewater. And one of the best things we've done for water quality in the US is to have municipal waste systems, so-called water treatment plants. Those have done a phenomenal job in cleaning up our water and our waterways, and making sure that the water either we're using for recreational reasons or for economic reasons or for drinking is safe and can be used for those particular purposes. In fact, I would say municipal water treatment plants from an environmental perspective are some of the most important and beneficial environmental tools we've ever had, because they took a very low water quality US, and despite the fact that we still have a lot of water quality problems, they made water quality in the US much better in a very short amount of time period. So we can subsidize municipal waste treatment subsidies to increase the amount of treatment that cities are doing, because it's very expensive to do this. We want cities to do more of this. We want localities to do more treatment of wastewater, because it's a way for us to, in a way, kind of take care of the pollution problem before it becomes a problem. I think of municipal wastewater treatment in the same way that I think about companies that put scrubbers on smokestacks. So I've talked about in class how companies will literally put, scrubbers on their smokestacks that will stop pollutants from making their way into the air. And municipal wastewater treatment plants can be thought of in that same way. But wastewater treatment plants are very expensive. They have high capital costs. And so there's a reticence oftentimes by local governments, even state governments sometimes, to spend the money to try to remediate wastewater. And instead, sometimes they'll just try to divert the wastewater into a particular source that's already dirty, that already can't be used. But then that's just growing the problem. It's not taking care of the problem. It's not actually mitigating it. It's just kind of diverting it. And then it's likely to become a bigger problem, later on in the semester. The other thing that we're doing in the US that I think is potentially going to be very helpful in this particular vein are the USDA water grants and loans. So there's a maximum grant of $1 million to communities with a significant decline in quantity or quality of drinking water due to an emergency. So like after a natural disaster, sometimes natural disasters take water treatment plants offline, or in fact, natural disasters will introduce effluents into drinking water in a way that needs to be remediated quickly. So the government has set up these funds that will enable it to do that. There's also a maximum grant of $150,000 to make emergency repairs and replacement of facilities on existing systems. And then another type of loans provide funding for clean and reliable drinking water systems, sanitary sewage disposal, sanitary solid waste disposal, and stormwater drainage to households and businesses in eligible rural areas. So you'll notice with water pollution, interestingly enough, a lot of times the water pollution problems are a little bit more pronounced in rural areas. And so that's been a lot of the focus. That being said, it does not mean that we don't have water pollution in big cities. It just means often in big cities, you often have a greater capacity to treat that water than rural areas do. And so we see better wastewater treatment occurring in big cities than we see in rural areas. And so we need to get those rural areas to get on board with it as well. I would say that nowadays, the thing that we're most concerned about with water pollution is non-point source pollution. Runoff and concerns of runoff have become huge issues. I read an article recently. I'll share this on the Discord. I read an article recently that talked about the runoff from airports. Airports use a ton of de-icer in the wintertime, and that de-icer makes its way as runoff. There's obviously fuel and oils and other chemicals used in the maintenance of airplanes, which can make its way off the tarmac and into waterways. So actually, the airports have now become sort of this hub of potential pollution. One way that airports have gotten around this is they utilize heated tarmacs, so that way the ice and the snow melts off from the heat and not from the use of a chemical de-icer. But obviously, that's going to be very expensive, and people are going to be reticent to do that, because of the cost. So overall, the use of cost-effective policies would reduce costs substantially while not affecting the benefits with respect to water pollution. Economic incentives would also facilitate change better than technology-based standards that are very rigid. The possibilities of using marketable permits for water pollution control are being explored for many bodies of water in the US. Again, we're seeing kind of the extension of these market-based mechanisms. Again, and it's like air pollution. One of the reasons why you're seeing more market-based mechanisms is that the traditional command and control approaches that have been utilized by the EPA are very costly and sometimes not even very effective. And so people have looked to market-based mechanisms, not just to save money, but also to actually elicit the reduction in environmental damage that they're seeking to do. Economic incentives, as is the case with air pollution, put pressure on sources to find better ways to control pollution. Remember, we are interested in internalizing the negative externalities. So the sources of pollution need to have some way that they recognize the damage that they're creating. And again, this is where economic incentives really shine, because they enable the internalization of that negative externality.